So we use an ANOVA. What does an ANOVA tell us? The null hypothesis. Like a t-test, the ANOVA tells us the null hypothesis that the means are the same. The experimental hypothesis, that the means are different. An ANOVA is an omnibus test. It is a test for the overall difference between groups. It tells us that the group means are different. It doesn't tell us exactly which means differ. An analysis of variance, that's what ANOVA stands for. A one-way ANOVA versus a two-way ANOVA. The differences between a one-way ANOVA and a two-way ANOVA can be drawn clearly on the following grounds. A hypothesis test that enables us to test the equality of three or more means simultaneously using variance is called a one-way ANOVA. A statistical technique in which the interrelationship between factors influencing variables can be studied for effective decision-making is called a two-way ANOVA. There is only one factor or independent variable in a one-way ANOVA, whereas in the case of a two-way ANOVA, there are two independent variables. One-way ANOVA compares three or more levels, conditions, of one factor. On the other hand, a two-way ANOVA compares the effects of multiple levels on two factors. In a one-way ANOVA, the number of observations needed need not be the same in each group, whereas it should be the same in the case of a two-way ANOVA. One-way ANOVA needs to satisfy only two principles of the designed experiment, that is, replication and randomization, as opposed to a two-way ANOVA, which meets all three principles of design experiments, which are replication, randomization, and local control. Go to the web links page and read more about the key differences between a one-way and a two-way ANOVA. An ANOVA. There's the one-way ANOVA, there are two-way ANOVAs, three-way ANOVAs, n-way ANOVAs, also known as Factorial ANOVA, and a repeated measures ANOVA. Factorial ANOVA. The advantage, it allows the examining interaction between different independent variables. This is an example of a one-way ANOVA with three groups: the experimental treatment, the traditional treatment, and no treatment, the control group. You have the mean, the standard deviation, the number of subjects. And you plug it all in, and the computer does the work. This is an example of a two-way ANOVA with two independent variables, treatment type and intensity. So you have the experimental and the treatment in a 2-week session compared to a 4-week session. So our independent variables, the experimental, the treatment, 2 weeks versus 4 weeks. Here's an example of a two-way mixed model analysis of variance ANOVA with one between and one repeated measure variable. So you have pre-test, post-test, experimental, and treatment.